Alright guys, explaining further the properties of alkenes we have studied in the previous videos that one of the product is major and the other product is minor, one has a greater yield and the other has lower yield. This is explained by Markonikov's rule or the stability of carbocations that is formed in the intermediate. So in an unsymmetrical alkene, if you add a molecule of HBr or steam, hydrogen atom can go to either of the two carbon atoms or double bond. But according to Markonikov, hydrogen will prefer to go to the carbon atom which already has greater number of hydrogen atoms and form a major product. So if we see this, we will see that during the reaction mechanism, which is electrophilic addition reaction, this double bond can break on either of the two carbon atoms. I have taken case 1 on the CH2 and the case 2 at CH. So if we follow the case number 1, we will get a secondary carbocation. It means that hydrogen, because we break the bond on this, so it has a negative charge and the H plus will add to the first carbon, and a positive charge will go to the central carbon atom. This is called secondary carbocation. But if I follow the other way around, if we break it to this central carbon atom, then we have a positive charge on the first carbon, and then we will have a primary carbocation, and positive charge is here, and hydrogen will be added to the negative carbon, which is the second carbon. So this is called secondary carbocation. What is secondary carbocation? It is a carbocation in which positively charged carbon atom is attached to one hydrogen and two carbon chains directly. Two carbon chains can be also denoted by two R groups. But in primary carbocation, hydrogen atom, a carbon atom which is positively charged is bonded to two H atoms and one carbon chain. So one R group. So according to Markonikov and according to the rules of stability, greater the number of R groups, greater the stability of the carbocation. This is due to positive inductive effect. Positive inductive effect means electron donating effect. So R group has an electron donating or positive inductive effect, and due to this, due to the electron donating effect, the positive charge density is reduced because of two R groups in here. But here only one R group reduces the positive charge density to a lesser extent. So greater the number of R groups, greater is the stability. That's why this carbon, which is positively charged, has two R groups, so it has more stability and it has major product to be formed. Whereas in this primary carbocation, it has two hydrogen and one carbon chain, so it has lesser stability due to lesser number of R groups, and therefore it will form a minor product. So this is depending on the stability of the carbocation that is formed by the unsymmetrical alkene.